In this lesson, we're going to look at how function notation can make predictable changes in graphs of functions. It says here, each part of a function notation makes a predictable change in the graph of the function known as a transformation. For example, making the x negative, f of negative x, will always cause the graph to change in the same way. So first we're going to look at rules that change y values, and we'll talk about why they do. It says we will use rules to change or move y values. These are the numbers outside of the function or that parentheses. So this plus 2 tacked on the end of the function is going to change the y by what it says, adding 2. So if I look at this, the reason is f of x, we could also use that as y equals. So we're saying take the y values and add 2. Here, this little graph that's in each of them, this blue shape like this, that's f of x. So when this says a of x, they're saying the new function a of x is going to be f of x plus 2. I'm just going to erase that so we can see it better. So doing this change, f of x plus 2, we'll take all of the points and move them up 2 because they're increasing the y's by 2. So we're just going to graph those. I'm taking each of these points and moving them up 2. Just to show what happened, for example, this point for negative 2 went to this point right here, which is 4, 0. So I can see that the y value went up by 2. So I'm going to sketch in this is a of x, f of x plus 2. Looking at that, basically the transformation name for that is a vertical shift, or sometimes we just say a shift up 2. So it's a vertical shift. We can get rid of the word vertical and just say up 2 is probably the way we see it the most. In contrast to that, next one is f of x minus 2. So we have this same starter function and we're moving it down 2 now. So this is a shift down 2 because we're subtracting 2 from the y values. So I just take each of those 4 points, and we know this function really has an infinite number of points. I'm just taking the ones that have, are shown with dots and are labeled with coordinates. So we move it down 2. So those are your shifts, your vertical shifts, up or down. Basically, if you see something tacked on with addition or subtraction at the end of the function, that's how it changes it. Moving down the page, we're going to look at our other types of y changes. So this one, we have 2 times f of x. And what that does is it multiplies the y values by 2. So pretty predictable, right? Before we were adding to them, now we're multiplying by them. So this is multiply y's by 2. And I actually want to write up here just so you have it in your notes. Add 2 to y's. And here subtract 2 from y. So looking at this, if I multiply these by 2, I'm just going to write one down. I'm going to use this one again. So this is the point for negative 2. If I multiply the y by 2, that's the x is always going to stay the same here. So it stays 4. Negative 2 times 2 is negative 4. So that point is going to move down. I'm going to erase that circle just so we can see it a little better. So that's going to move down to here. The one that has a negative 1 times 2 is negative 2, the y value. And then these with the 2's, if we double them, they're going to go up to 4. So basically the x's, look, you can see the x's stayed put and the graph just kind of went up and down and it's stretched away from the x-axis. So if I connect them, that's how they look. These points, and I didn't do a perfect job, that are right on the x-axis, those ones stay because their y values are 0, so when we multiply them by 2, they don't change. The name of this transformation is a vertical stretch. And in this case, because 2 is the number that's being multiplied, or is multiplied by f of x, it's a vertical stretch of 2. Notice the difference. The shifts just kind of keep the shape the same, move it up or down. The stretches stretch it away from the x-axis, or we're going to see on the next one, it's actually going to compress it down towards the x-axis. This one, it's the same setup, except now we're multiplying by 1/2. So we're going to multiply y's by 1/2. And what that's going to do is it's going to shrink it, right? Shrink it towards the x-axis. So 2, 2 is going to go to 2, 1. Negative 1, 2 is going to go to negative 1, 1. This is a negative 2, so it's going to go to negative 1. And this one's going to have a fractional value, right? We have a negative 1 here, so that's going to go to 1/2. Be really careful. The x's do not change here, and we can tell that too. Do you see how that x is still x? It's just the y's. So I'm going to do the best I can with my tablet to connect these and make it look decent. Now, this is the same thing that's happening in terms of what we're doing to the y's as the last one, but when things get shrunk, we don't call them stretches, we call them compressions. So this is a vertical compression of 1/2. On the next page, we're going to start to look at some other types of changes. Now, what gets a little tricky, and I'm just going to read this first. It says we will use rules to change or move the x values. These are the numbers inside of the parentheses, right, where the x is. When changing the x numbers, we do the opposite of what's written, which at first glance just seems like a rule that doesn't make sense. So before I go back to that, I'm just going to explain what opposite means. So you would think that that would move it right 2, okay, or add 2 to the x's. We actually subtract 2 from the x's. And the best way I can describe this, you know how if we had factors like this, maybe I was solving an equation, even though the factor says x plus 3, the root, or the actual value that's on the graph, is a negative 3. And the other root, if it says minus 2, is really a positive 2. So it has to do with the setup of the equation. Basically, it's opposite for those x's, and think of it like factors versus roots from the polynomial unit. So now we'll get to it. So we're subtracting 2 from the x's when we see x plus 2 in the parentheses. So it's going to move it over here, 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 it's right on a line, and over here. So just like the vertical shifts, the shape of the graph doesn't change, it just moves somewhere. So this is called, it's a horizontal shift, and we'll just say shift left 2. Now, in the same way, we might expect the next one, x minus 2, to move it left, but it actually moves it right. Just like if I have a factor of x minus 2, I really have a root, or the thing on the graph is positive 2. So this is going to add 2 to the x's. So we'll end up moving it in this direction. Okay, so that ends up being a shift right 2. Now we're gonna have a page with all the rules kind of summarized. This is just introduction to how things work. Now we do later in the year do horizontal stretches and compressions, so compressing it and stretching it in the x direction, but in this unit we don't. It kind of fits in better with a different unit to see those and see the differences between those and some other things we do. So those are coming, but we do not do them here. The last 2 transformations we are going to do are reflections. So it says in the next 2 problems, we will either see f of x or x is multiplied by negative 1. So here's f of x being multiplied by negative 1, or negative f of x, right? We could write this as negative 1 f of x. We just don't usually write the 1. Or here, this is like f of, sorry, I'm having some trouble with my stylus, negative 1 x. Now, the thing we want to think about, we want it to fit with what we know. We know with the y changes like this, we do the same thing, right? So we'd multiply by negative 1, With the x changes, we do the opposite, so we divide by -1. But multiplying by -1 and dividing by -1 both result in negation. So if I had, for example, 3, and I multiplied it by -1, that would give me -3. But if I had 3 and I divided it by -1, I would also get -3. So all that's being said, even though those opposite rules still apply, in both cases, we basically just negate, because negating is the same thing as multiplying or dividing by -1. So you can listen to all that about why it makes sense with the rules, but ultimately what we do is we negate either x or y depending on the location of the negative sign. So in this one, we're saying negative f of x. So that's like saying negative y, right? Because f of x is y. So this is like saying negative y. So we make, actually I'm just going to write negate y's. It's probably a better way to write it that's a little shorter. So negate the y's. So if I negate the y's, it means I'm taking all the points and I'm basically, this is a -2, so I'm going to graph it at +2. This is a +2, so I'm going to graph it at -2. Negating the y's, right? Y is up and down. +2 to -2 and -1 to +1. Now, when I look at that, I made all the y's negative, but interestingly, by making the y's negative, I flipped over the x-axis, okay? So we look, it didn't go over the y-axis back and forth, it went over the x-axis, right, because it went up and down. So this is called a reflection over the x-axis. The next one, basically the same deal. Now the negative sign is in with the x, so we're going to negate the x's. So we're going to take all the x's. So I have a -3 here. I'm going to make it +3. I have a -1, so I'm going to make it +1. I have a +2 here, so I'm going to make it -2. This top part's a little confusing because it's just straight across. And then I have a +4, so I'm going to make it -4. So I'm going to erase a little bit of stuff just so it's not complicated. Okay, so those are my new 4 points. I'm going to connect them. And because the graph is a little bit symmetric over the y-axis, it's a little bit hard to see on this one, but basically what happened is by making those x's negative, I reflected over the y-axis. So later, when you feel like it's super tricky to remember that when I make the y negative, it goes over the x-axis, and when I make the x negative, it goes over the y-axis, it feels kind of backwards. These pictures, if you can keep them in mind, should make sense as to why it works that way.